Let's look at the overall reaction first. So what we adding onto the benzene? We add sulfur trioxide in sulfuric acid. Okay, both are concentrated. We call this combination of SO3 and sulfuric acid fuming sulfuric acid. That's what how they call it. The end product, we have a sulfonic acid. Replace one hydrogen onto the benzene ring. Okay. All right. Start with the sulfur trioxide. Okay. Sulfur trioxide is not stable. The SO double bond is actually not really a SO double bond. It's highly polarized. What I mean by that, so these two are resonance structures, but the real sulfur trioxide, the bond SO bond is actually have more single bond character than a double bond character. The reason is the overlap is between sulfur and oxygen. The double bond overlap, like so, we use are not effective. Oxygen use sp, both are sp2, of course. Okay, but oxygen use 2p orbital, but sulfur is 3p orbital, which is the next energy level. So when the size doesn't match, the overlap is not as well. Okay, so basically my point is this sulfur is highly electropositive. So that's my point. So what's going to happen is, since sulfur is highly positive, benzene can attack. Okay, so you get a sulfonyl group onto the benzene ring, and that's your sigma complex right there. So that same thing, just like you saw in the chlorination or bromination. Okay, the next step is we have to restore aromaticity. Since we use concentrated sulfuric acid, the solution is in water. Water comes in, attack, depronate that proton to form a re-aromatization, reform aromaticity. Okay, and since the reaction solution is in acidic solution, so we have to pronate the sulfonyl group, and you have ta-da, sulfonic acid in. All right, that's it. Very similar mechanism as you saw in the bromination and chlorination. Move on to the next one. Really simple and same thing. We call nitration.